Hello, welcome to today's class. In today's class, we will talk about the A-star search algorithm. In the last class, we talked about the greedy best first search algorithm, and we saw that in case of greedy best first search, the evaluation function fn is equal to the heuristic function hn. So whatever is the value of the heuristic function that we assign as the f value of the node. And then we saw that for greedy based first search, the algorithm was not optimal. Now in today's class, we are talking about A star search, and for A star search, the evaluation function fn is given as the sum of the g value and the h value of a node. So f of n is equal to z of n plus h of n, where n is our node under consideration. So what we mean by z of n is the cost of the node n from the start node. And what we mean by h of n is the estimated cost to get from node n to the goal node. Let me further explain in these terms using an example. So let's say we have a start node in our state space and we have a goal node, and in between the start node and the goal node we can have so many other nodes, but I am showing only one of such node and I'm calling it the node n. So we have start node, we have the goal node, and I am selecting one of the other node as our node n. Now during our search process, our start process, the search process will start at the start node, and after we proceed few steps in our search process, we may eventually reach this node n. Of course, before reaching node n, we may have generated other nodes, and those other nodes are not shown in this diagram. But what I am trying to say is that during our search process, we will eventually reach the node n through some path, and whatever is the cost of this path, that we call as z of n. So g of n gives the path cost from the start node to node n. Since we have already generated the path from start node to the node n, this value of gn is actually the actual cost of the path. Since we have already traveled the path, so we know what is the cost of this path. Now from we are at node n, but our destination is our goal node. We want to reach the goal node, and since we have not further explored, so we don't know what path will actually lead us to the goal node from node n, because the rest of the steps in the search process has not been performed yet. So we do not know what would be the path from node n to goal node, and finding this path from node n to goal node is actually the objective of the search process. And now but we know that there may be some path which will lead us from node N to the goal node. And since we have not explored this path yet, we will not be able to tell the exact cost of this path. All we can do is estimate that this may be the cost of traveling the path. And we use a function h of n. So h of n will give us the estimated cost of the cheapest path from node N to the goal. So there may be multiple paths from node N which will take us to the goal node, and among these multiple paths, whichever is the cheapest path, we are considering that, and the estimated cost of this path we are calling it as h of n. So now f of n is nothing but z of n plus h of n. So we know this is z of n and this is h of n. So f of n will be this cost of the path which starts at the start node and goes through node n up to the goal node. So f of n is z of n plus h of n. And since we already said that this path from node N to the goal node is the cheapest path, so we can say that Fn is the estimated cost of the cheapest path solution path through node N. So the F value for node N will tell us what would be the cheapest path from the start node to the goal node through node N. So I hope this terminology is clear now. And now let us look at the application of A-star search on our problem that we had been using so far, which is about finding a route from Arad to Bucharest. And since our destination is Bucharest, and as we had discussed in the last class, we used the straight line distance from all the cities, from each of the cities to Bucharest as our heuristic function. So we use the straight line distance as our heuristic function, and we listed these values as the straight line distance from each of the city to Bucharest. So for example, the straight line distance from Arad to Bucharest is 366. From Craiova to Bucharest, it is 160, the straight line distance. And from Bucharest to Bucharest, of course, it will be zero cost. So with this, now to perform A-star search, we will need this h value, and we would need this step cost also. So what I mean by step cost is the step cost from Arad to Sibiu is 140. From Sibiu to Figueres, it is the step cost is 99. So distance is 99. So in case of A-star search, we will use both the h value and these step costs. In case of greedy based first search, which we studied in the last class, we did not make use of these step costs. We only use the heuristic value. Now we want to find a path from starting at Arad up to Bucharest. So our start node is Arad. and we need to calculate the F value of Arad. And as I had said, the F value is nothing but the sum of Z value and H value. So now the G value of Arad is, so what we mean by the Z value for a given node n, it means what is the cost from start node up to that node n. So since the node under consideration is Arad, so the distance from Arad to Arad itself will be 0. That's why the Z value is 0. However, the H value is obtained from this table, which is 366. So the F value for Arad is 0 plus 366 is 366, which is also shown here, the same calculation. And since Arad is our only node, in our fringe list only Arad will be present. Now this fringe list in case of A star search is a priority queue ordered on the F value. So if we have multiple nodes, if we have multiple fringe list nodes, how will we put those nodes in the fringe list is based on their F value. Whichever node has the lowest F value, that would be put at the front of the list. To start with, since we have only one node, so Arad will be at the front of the list. So when we have to select the next node, Arad would be selected for expansion. And when we expand Arad, and the different actions that are possible at Arad is we can go to Sibiu, we can go to Gerend, or we can go to Timisoara. And hence 3 nodes will be generated. Now we have 3 fringe list nodes. So we have now all the 3 nodes that has been generated when we expanded the node Arad. These 3 nodes, they have to be put into the fringe list. And in what order will they be put in the fringe list? For that we have to calculate the F value of Sibiu, the F value of Timisoara, and we have to calculate the F value of Gerend. And we already know what is the formula to calculate the F value. For example, the F value of Sibiu will be given by the G value of Sibiu plus H value of Sibiu. The F value of Timisoara will be given by the G value of Timisoara plus H value of Timisoara, and the F value of Gerend will be given by the G value of Gerend plus H value of Gerend, because we know F of n is equal to G of n plus H of n. Now the G value of Sibiu, what we mean by Z value is what is the cost or what is the distance of Sibiu from the start node. And as we can see, from Arad to Sibiu, the actual cost is 140, and hence the Z value of Sibiu is 140. And the H value of Sibiu is given from this table, the straight line distance. So what would be the straight line distance from Sibiu to Bucharest? It's 253. So F value of Sibiu will be 140 plus 253, which is 393. This same calculation is also shown here in the diagram. F value of Sibiu is 393. Similarly, the F value of Timisoara will be 447, which is 118 plus 329, which is 447. And the F value of gerund will similarly be equal to 449. And when we compare the F value of these three nodes, we see that CBU has the lowest value. It is the lowest F value. So CBU will be put into the fringe list at the start, followed by Timisoara and gerund. So this is a priority queue ordered on the F value. Whichever node have the lowest F value, that node will be put in the front of the list. So now CBU will be selected for expansion next, and now from CBU I can go to Figueres, I can go to Rimniku, or I can go to Oradea, or I can go back to Arad. So since we are using tree search, repeated nodes will be allowed, so we may again go back to Arad. So this diagram shows the 4 nodes that are being generated, and now we have to calculate the F value for all the 4 nodes that has been generated. So you have to calculate the F value of Arad, you have to calculate the F value of Figueres, you have to calculate the F value of Oradea, and you have to calculate the F value of Rimniku. Now to calculate the F value of Arad, that is of this node, when to calculate the F value of this node, we have to calculate the Z value of this node N, which is Arad in this case, G value of Arad plus H value of Arad. Now to calculate the G value, what was the G value? G value is the actual cost starting at the start node up to that node N. So here we have 2 step cost. The first step cost from Arad to CBU and the second step cost from CBU to Arad. So when we add these 2 step cost, then we will get the G value. So 140 is the step cost from Arad to CBU, and the next 140 is the step cost from CBU to Arad. So it will be 140 when we go from Arad to CBU, and it will be another 140 when we go back from CBU to Arad. So 140 plus 140, 280 would be the G value of this node, of this repeated node Arad. And the H value again we'll obtain from this table, which is 366. Hence the F value of this node will be 140 plus 140 plus 366, which will be 646. And the same calculation is also shown here in the diagram. It shows that the F value of Arad is 646. Similarly, the F value of Figueres will be given by 140, which is the distance from Arad to CBU, plus 99, which is the distance from CBU to Figueres. So 140 plus 99 gives the Z value of Figueres, and plus we have to add the H value. H value is 176. Hence the F value of Figueres is 415. Similarly, the F value of Oradea will be 671, and the F value of Rimniku will be 413. So now we have 6 nodes in the fringe list, 4 nodes here which has been newly generated, and 2 nodes from the previous step. So total we have 6 nodes, and among these 6 nodes, whichever has the lowest F value, that would be put into the front of the fringe list. And as you can see, here it is 447, here it is 449, here it is 646, here it is 415, Here it is 671 and here it is 413. So Rimniku has the lowest F value and hence Rimniku will be at the front of the fringe list. And it also means that Rimniku would be selected for expansion next. And when we expand Rimniku, the possible actions are we can go to PTSD, we can go to Craiova, or we can go back to CBU. And these are the three nodes that will be generated when we expand Rimniku. And now we have to calculate the F value for these three newly generated nodes. So you have to calculate the F value of Craiova, which will be Z value of Craiova plus H value of Craiova. You have to calculate F value of PTSD, which will be G value of PTSD plus H value of PTSD, and F value of CBU, which will be Z value of CBU plus H value of CBU. And now to calculate the F value of Craiova. So Craiova is our node here. So we have to calculate the G value for Craiova, and a G value is what was the meaning of the G value is what is the distance from the start node up to this node N. In this case is Craiova. So if we follow from start node, we have to come to CBU, then we have to go to Rimniku, then we have to go to Craiova. So now there are 3 step costs involved in the calculation of the actual cost from Arad to Craiova. So now we have to and the first step cost is 140. So from Arad to CBU it is 140. The second step cost from CBU to Rimniku is 80. So from CBU to Rimniku is 80. And then from Rimniku to Craiova, it is 146. So the G value for Craiova would be given by 140 plus 80 plus 146. And finally the H value we obtain from this table, which is 160. And when we perform this addition, we get that F value of Craiova is 526. And that's what is also shown here in the diagram. In the same way, we will calculate the F value for PTSD, and it comes out to 417, and the F value for CBU is 553. With these 3 newly generated nodes, now we have 3 plus 3 6 plus 2 8. So now we have total of 8 nodes in the fringe list, and among these 8 nodes, the node with the smallest F value is Bucharest, which has the F value of 415, and hence Bucharest will be at the front of the fringe list, and it is Bucharest which will be selected for expansion next. And if we look at this map, from Bucharest we have 2 actions possible. We can go back to CBU or you can go to Bucharest. So now when we expand Bucharest, these 2 nodes are being generated, CBU and Bucharest. And now we have to calculate the F value for each of the 2 nodes. So F value of CBU will be given by the G value of CBU plus H value of CBU, and F value of Bucharest will be given by G value of Bucharest plus H value of Bucharest. Now when we want to calculate the F value of this node, we have to consider this 3 step cost, and this 3 step cost will be 140 plus 99 plus 99, and the H value of CBU is 253. And when we perform this addition, we get the F value of CBU to be 591. And similarly, the F value of Bucharest will be 140 plus 99, And this calculation is not correct. So please correct this calculation. It should be 140 plus 99. Sibiu to Figueres is 99, and Figueres to Bucharest is 211. So this should be 211, and the G value of Bucharest is 0. So this is 0. So instead of this 299, it should be 211. And when we perform this addition, it would come to be 450. So the F value of Bucharest is 450. And now we have how many nodes in the fringe list? We have 1 plus 2 3 plus 1 4 plus 3 7 plus 2 9. So you have 9 nodes in the fringe list, and among these 9 nodes, and the node with this smallest F value is PTST, which is the F value of 417, and hence PTST will be at the front of the fringe list, and hence PTST will be selected for expansion next. One interesting thing here is, although we have generated our goal node here, we are not going along this path. We are selecting the node with the smallest F value first, because we know that the F value of this node Bucharest is 450, and we know that the F value of PTSD is 417. So maybe through PTSD we may be able to find a path to Bucharest whose F value will be less than 450, and that's why this algorithm, A-star algorithm, although Bucharest has been generated, we still explore PTSD first. So from PTSD we in fact have one path to Bucharest, and the other path is we can go back to Râmnicu or we can go to Craiova. Hence 3 nodes will be generated: Bucharest, Craiova and Râmnicu, and we have to calculate the F value for each of the 3 nodes. Now to calculate the F value of this node Bucharest, we have to add this step cost 140 plus Sibiu to Râmnicu is 80, and Râmnicu to Pitești is 97, and Pitești to Bucharest is 101. This edge is 101. So we have to add these 4 values to get the G value, and plus H value of Bucharest is 0. So that gives you the value 418, and that calculation is also shown here. Similarly for Craiova, it will be 615, and for Râmnicu it will be 607. So now among all the nodes in the fringe list, the node with the smallest F value is Bucharest, which has a F value of 418. Now Bucharest will be selected for expansion, and when we perform the goal test, we see that Bucharest is in fact our goal node, and hence it means that we have found a solution, and the solution is Arad to Sibiu. This is our solution, and hence this solution would be Arad to Sibiu, then Sibiu to Râmnicu, Râmnicu to Pitești, and Pitești Bucharest. So this would be the solution for the search problem. And in case of greedy best first search, we actually found the path Arad to Sibiu, Sibiu to Figueres, and Figueres to Bucharest. That was the path that was returned in the last class by the greedy best first search algorithm. And here, when we used the A-star algorithm, we actually found a new path as a solution, and this new path is actually more optimal. In fact, we will discuss in the next class, and we will see that A star search algorithm is actually optimal algorithm under certain conditions of the heuristic function. So with that, I would like to end today's class, and in the next class we will talk about optimality and completeness of the A star search algorithm. So we'll meet again in the next class. Thank you. Bye.